Good morning, everyone. Welcome to the MEL 2550 classroom session today on supercharging research using AI tools. My name is Raj Chaudhury. I am at the University of South Alabama. I'm the director of the Innovation and Learning Center there. Distinguished panelists today, we have Sergei Gleyzer, University of Alabama. We have Gerry Dozier, Auburn University, and we have Jim Locke from Auburn University, Montgomery. Okay. So we'd like this to be an interactive session because I know we have people from lots of different disciplinary backgrounds and institutional backgrounds. But I've asked Sergei to get us started because earlier this month, just a few days ago, the ultimate pinnacle of prizes in research were announced. The Nobel Prizes in Physics and Chemistry both went to work that cites artificial intelligence, machine learning, and some fundamental aspects that have come from natural systems into that applied work, right? And so you might wonder, why would the Nobel Prize in Physics or the Nobel Prize in Chemistry be given with citations related to AI? So Sergei has volunteered to get us started with that particular discussion to share a little bit about that work and how some of these applications have come out of that. Sergei.
Thank you much, Raj. I'm Sergei Gleyzer. It's a pleasure to be here. Thanks for having us. So I'm a scientist, and I've been doing AI in science for quite a long time. But I think what you mentioned, the Nobel Prizes and everything, it's an indicator that it is the age of AI in science. I used to say it's the future, it's actually the present. Because the work that's cited also is the work that happened over the, some of it in the 70s, 80s, and later on. What's interesting is that the two prizes, the one in physics and the one in chemistry, are for different things. So the one in physics is what I would consider to be the one where it's science for AI. Because physics, interestingly enough, the algorithms that were cited and a lot of the progress that's happened in AI has actually been driven a lot also by progress in physics and understanding of what's happening inside the black box, right? And how do we build better algorithms, more potent algorithms? And some of it solved a lot of the problems. For example, the work of Jeff Hinton and so on that enabled the deep learning revolution, which allowed all these other things you see, all the neural networks that power transformers and large language models would not be possible if not for that fundamental work. Same for Hopfield and those are very early ideas that came from physics. And what's interesting is you need physics and science to be sort of like the engineering also behind and understanding the fundamentals of this. And that's how we also can grasp, to understand, and hopefully also interpret what's happening. So that's the one in physics. The one in chemistry I consider to be more AI for science, because they actually use tools or developed and further enhance some or it's already existing tools, whether it's graph neural networks and other things that DeepMind has done, and then apply it to a really important problem in science, like protein folding and AlphaFold and so on, and make important contributions to science. And I think both things are happening. And in some sense, science is a mature field when it comes to AI because we sort of grew up with it and contributed to its evolution. So it's very exciting, but I'm also very excited about also many other fields where AI is just coming into. And I'm also very excited about us sharing that experience on how, how it can impact our field in a very positive and impactful way, also with other disciplines that are just now starting to, tackle some of these questions. And, nobody would do astronomy now without a telescope, right? Or something like that. This is a tool that everybody, so it's that way in science now. It's an invaluable tool. And I think it's a precedent for many more other discoveries that are coming up.
Great, thank you. Gerry and Jim, let's hear from you guys a little bit. Then I'm going to come back to Sergei with an application question for you as well.
Okay, very good. Good morning. My name is Gerry Dozier. I'm a professor in the Computer Science and Software Engineering Department here at Auburn University. My research area is in adversarial AI, and I'm applying it to cyber identity protection and privacy. I'm trying to give people back their anonymity. So when you look at when you're on the internet or whatever you're doing, you can be identified by your actions. What I'm trying to do is develop AI tools that will allow you to have your anonymity and not. So I started off with text, because basically your style can be basically identified, and I'm looking at ways to say, hey, how can we make it so that people cannot identify you based on your tag, based on your writing style. And so that's pretty much what I'm doing. I think this is very interesting to what was said before. When we look at artificial intelligence, we kind of see this thing earlier with science for AI and AI for science. We're going to continue to see that cycle. And it's with every type of way that artificial intelligence can be applied, because it's always going to be with a new application, right? You come up with different perspectives of how AI can be used and molded to solve that particular application. I think it's very excited, and I like that circular property that we see with AI and everything.
Thank you.
Hi, good morning. Jim Locke. I'm from Auburn University in Montgomery. And the first thing I noticed is, and this was completely random, but we kind of go like a product does, right? You know, fundamental science, engineering, business. I'm in the College of Business at AUM. And my interest in research is really a lot more engineering and science, because I'm very interested in what is going on in the black box. I'm a recent PhD. My dissertation was in that area of activation functions and neural networks. And while I was in PhD school here at Auburn, in the business school, you know, as a graduate student teaching sophomores introduction to MIS, I'd spend a couple of days talking about AI, and I always had a bunch of kids, several kids in the class would come up and want to know more about it. Unfortunately, there were no courses available for them to take in the business school. So we started having these Thursday evening volunteer sessions, and it turned out to be tremendously successful. And I was very fortunate after I graduated that Auburn and Montgomery allowed me to establish an AI lab there, and we started teaching AI subjects. We have 4 that we're teaching to graduate and undergraduate students at AUM. And we recently got approved for a master's degree in AI in the College of Business. The first question I get is, why AI in a business school? And my stock answer is always the same. When you look at the headlines, when you look at the news, there's not much at all in there about engineering or fundamental science. It's all about, how do we apply this? How do we use it? What are the ethics? All of that comes to leadership in good management. Where do we teach that? In a College of Business. So that's why we're doing it at AUM in this College of Business. One thing I hope we can talk about today, and I'd love to hear y'all's thoughts on this, because y'all are at much larger schools than I am. One thing I learned at AUM in doing this is, in schools, they are typically, my background is business, they are typically very command and control structure. They're bureaucracies, things get done a certain way. We're in a phase now where it is very much exponential change. And it's going to require a lot of creative thinking, a lot of trial and error. And those are very organic kind of business practices. I think the biggest challenge in supercharging research at your institutions is going to come from, what is the fit between something that needs to be organic inside this big command and control organization?
Thank you. So I think, Jim, the direction that you took this last piece of the conversation is actually dovetails nicely with the point that I wanted to make and get some feedback from Sergei. So I used to teach physics for many years, right? We talked about how understanding the science is necessary to generate these new kinds of ideas for applications and things like AI. I know you do some work on like dark matter, right? And so one of the things that excites people, right, about getting into a field like physics is the mysteries of the universe, right? And dark matter is one of those mysteries of the universe, right? So talk a little bit about your work in the search for dark matter and how in all of our fields we can leverage that kind of natural curiosity and inspiration that comes from these materials into then the serious work, right? Because studying physics and computer science and even the things you're talking about in College of Business requires serious intellectual effort, right? So how do we motivate students to put that serious intellectual effort into it through these cool things that we can do?
Well, thank you very much for this question. Indeed, dark matter is one of the biggest questions, one of the biggest mysteries in science today, I would say, in physics and astronomy. And it is something very motivating for lots of people, including myself, to be able to understand it, or maybe figure out what it might be and how the universe came to be the way it is. We wouldn't be here if not for dark matter, basically. There wouldn't be galaxies or things life as we know it, right? But what it is a mystery. And by the way, it's an invisible matter. You can't see it. It only has gravitational pull, and no one really knows what it is. And for that reason, one of the ways we look for that is on all sorts of scales. So I'm a particle physicist, so I work at CERN. I'm a member of the CMS collaboration, a large collaboration of scientists. It takes a huge village to make progress in these big science endeavors. And one ways we do it is we collide particles in a large accelerator, somewhere below Geneva, between Switzerland and France, and near the Alps. Very fantastic location. If any of you have a chance to visit it, we'll try to organize a tour for you. It's beautiful. It's like the world wonder of science. These are 4-story building detectors, billions of wires everywhere. It's something to see. But the ultimate goal is to actually make progress on these big fundamental science questions. So one way is if dark matter happens to be a particle, and there's many theories that predict that, could we create it in a lab, right? It's naturally maybe created another, outside of, this planet should be everywhere here too, from what we understand. So that's one way, is we smash particles and we try to look for dark matter. Another way is changing scales. These will be the smallest scales to the largest scales. So I'm also a member of the Vera Rubin Observatory and the LSST collaboration, which is just about to start taking data. This is a telescope which is named after Vera Rubin, who is, as many of you might know, she's the first person to actually postulate that there may be dark matter based on the evidence of galactic rotation. And this telescope is going to take a movie of the sky for the next 10 years, the most high-resolution camera we were able to build. It's just about unveiled now, and it's going to start taking data next year. And it's going to be like the window into the universe for astronomy. It's one of the biggest things. Like James Webb, this is my opinion, even a bigger deal. So there, you're dealing with images of galaxies, and we're based on that, dark matter will have different effects on certain things we can observe. And so we're going to get a lot more data than we've ever had and hopefully be able to probe it. And we use machine learning to do it. That's sort of the key part. AI and machine learning is critical in both of those efforts to be able to identify identify dark matter potentially, figure out what it is and what's happening. What's interesting is that to do it, the techniques that we developed to do these searches have been useful much broader in all kinds of scales. So a couple of years ago, the same technique to identify dark matter particles in the detector, and we used also to look for dark matter in these galaxy images called gravitational lensing phenomena. We actually applied in, I want to say our scales, but it was applied to find one of the few forming exoplanets, worlds outside the solar system. So you can think, from particles to galaxies to exoplanets, but you can use similar techniques to be able to make those discoveries. That's what's, I think, is very exciting. And the questions themselves are very exciting. And there are many questions outside of science that one can tackle, but these algorithms can make that possible and bring those discoveries much sooner than they would happen otherwise.
Thank you. Gerry, something that Sergey mentioned, and I read in your profile. I just Googled these guys like last week, right, to find out what they did. Is that you're building a tool to try to help people build high-performance collaborative teams, right? And so particle physics, so I'm a physicist. I did my first undergraduate research at Brookhaven National Lab, okay? And we were on my undergraduate thesis advisor, he's the one who got the credit, but he would be one out of like 75 authors on a paper, right? This is the joke about being on physics. And what did he do? His contribution to this one particular paper was providing my cheap undergrad labor to that experiment, right? So I sat in the lab and just like, ran things on PDP-11 computers. Some of you might remember that. This is really prehistoric for computers, but some of you hopefully here are of an age will remember the PDP-11. And so 75 people, right? Now, those teams were put together by word of mouth, by knowing who was where, what not, right? In this new age, when we want to tackle these problems, where we don't know who all the players are, and we cannot just rely on our personal networks, right? Can you talk a little bit about your approach and how you are going about trying to help people create high-performance teams?
Right. Very good. Yes. So also another hat that I wear is I'm the technical lead for something that you may have heard of called AI at AU. Okay, and so AI at AU, basically what we've been given is a grant to kind of bring everybody that's doing AI research or AI education at Auburn University together. Okay, so right now we have about 150 faculty members that are all passionate about AI research and AI education, okay? Now, the next thing is, how do we build teams? How do we put people together? And what I thought of was, okay, we have this thing called eHarmony, right? And we know, yes, we know how that works, right? So what I and my students did is we set out to create something called our harmony, research harmony. And here's what we did. We said, what we'll do is we'll go ahead and, everybody in AI at AU, they have a web page, and on that web page, they have their research interests. So we have 150 faculty members. Wouldn't it be real cool to see who's close to who, right? That way you can kind of see, and it's a nice little globe, like 3 dimensions. It spins around and you can stop it and see who you're connected to. But what we did is we just went out and scraped web pages of the folks that were in AI at AU. And we put this through something called Doc2Vec, right? Got a vector out. This is kind of what we do with large language models. And so now what we can do is we can start clustering these folks, right? Based on their research interests. And so we did that, and it was pretty interesting. And you can kind of see, you could see who you're closest to in terms of research interest. And then we had another weird problem, okay? And that was, all right, so now we know, we can say, well, I can give you who you are and who are the 5 people that are closest to you in terms of research interest. And the next question was like, okay, well, what are they gonna do? They're close with research, what are they gonna do? And so what we did is we just punted to BARD, right? And so what we did is we gave each faculty member, we let them know what their research interests were, and 4 of their closest colleagues to them, right? And then we gave it as they were seed emails. We sent this out to everyone. And it was a seed email. You can put it in the BARD, and then it would actually come up with a lot of different activities that the 5 of those people can work on. And some of it was good. Some of it was like, no way that's going to happen, right? But it was really good. What we then did is we moved on to something called Art Harmony 2, where now what we're doing is we're looking at your Google Scholar pages. So we're looking at the papers that were written, because that's going to give us a better match. And what we now can do is we can take BAAs, broad agency announcements. We can put it into our Harmony 2, and we can come up with teams. And I think that's really important, because going forward, we need to come up with teams where we match one another. And I think AI and these large language models do a really, really good job of putting people together.
Thank you. Jim, could I get you in real time to react to that? Colleges of business teach things like organizational leadership, organizational management, right? In a world where our harmony type things exist, or some other productivity harmony type things exist, how do you guys start to think about how do either CEOs of corporations, management, or even teaching in business schools, how does that field evolve?
Well, I think those kind of tools, we're going to see a proliferation of that sort of thing, because it's, business guys like to find what's efficient, what's going to lead to profit, what's going to lead, that's their interest. So when you have something that is so low cost but high impact, organizations will adopt it, and they will tweak it for their particular need. And then I think a university setting is a great place to begin with this, because we're used to taking risks where we may fail, and and we can learn a lot here, and then we can pass that on into the commercial sector, to government, where the need to be right is, and have a good pathway to how to get to right, where we've got some good definition of that. But if I may, if I could go back to your original question, like, how do we stimulate research, and what's that going to mean? Usually us business guys are not controversial. We tend to avoid that, but let me be controversial for a moment, if that's okay. I said earlier, my background was in business. When I got into school for a PhD in a business school, and was learning how to do research and what mattered in my department, I noticed that there's this laser focus on just 4 or 5 journals, and you just got to publish there. And you got to just incrementally move things forward. And I thought, well, that's a curious model. And there was so much value placed upon that. But I think that model is going to have to change, and just because of what we can now do. This is more in the behavioral side of things, which is where business kind of plays. But we are able, using AI, to gather so much more data now in such a different way. I mean, one of the first research projects I was involved in was we brought college students into a setting and interviewed them. Well, okay, that's a representation of the population. And as the physicists teach us with the slit experiment, that observed experiments behave differently than unobserved experiments. We can now gather data that has been passively gathered or assembled to where we can observe people's decision-making, and they don't know that they're being observed. And that's not a bad thing, but the AI will reveal on much larger scale of what's going on in various systems. And these are systems of commerce, systems of interaction, systems of research, where the p-value is probably not going to be the arbiter of what gets published and what doesn't in the future. We're also in this area of this hyper-fast change, this exponential change that is going to pressure us for more and more research quicker and quicker. But I think we're going to enter an era where we can start looking at much larger questions and more interesting questions than just incrementally moving the needle, where people can do what I think inspired them to go get a doctorate in the first place, where they can do that. They can say, there's a big question, I want to answer it. And I don't have time to do that because, oh my gosh, I got to get a paper out this year. With AI, we're going to be able to gather that data and understand it better on a much shorter time horizon. And I think the impacts are going to be greater as well. I'm really looking forward to that day because I think it gives us a chance to do what Gerry's working on. Imagine if I'm no longer sort of relegated with, I need to very quickly work with colleagues in my area on this particular problem because we need to publish something. Imagine if I can work with Sergei or Gerry, in fundamental science or in engineering, that we can think about what is a bigger problem that we can go tackle. I think those kind of opportunities are going to really stimulate interest in research and excite students and attract really bright students in the future. And I really welcome it.
Thank you. Sergei has a follow-up to that.
Yeah, I think your question was also about what is exciting and what gets people excited about things. And of course, one of the things in science is because some of the questions you mentioned are really fundamental about life and the universe and everything, it's easy to get people excited about it. But there are many, many exciting areas. At the same time, there's no shortage of technical students or postdoc, graduate, undergraduate students in the technical fields who are, trained and have the necessary tools to go and build, those AI algorithms and those solutions for this. But there are many fields, and maybe some of you here in the arts and humanities, who have just as fascinating questions, if not sometimes even more fascinating questions, depends on who you ask. But maybe there's not such a pool of students and that you could rely on to work on this. So me being an experimental physicist, we did an experiment and a little anecdote. A faculty member in one of the departments, modern languages, came to me last year and said, look, you're the AI guy. I have this problem. I don't know anything about AI. And many of you may be thinking, well, how do I get into AI? How do I get into these projects? How do I supercharge my research, right? Beyond just using the tools. Can I build something that addresses a big need in my field? So he came and says, look, I understand there is a problem. I see the problem. They've scanned tons of books and tons of things, but the modern tools for OCR and optical character recognition are either too slow or too expensive or inaccurate, or a combination of that. You can't search through them. You can read it, but you can't search through them. You can't transcribe them accurately, right? And I say, well, I kind of have an idea how to solve this problem, but I'm doing science and all these other things. And so if there was a student and there was somebody we could work with, we could move this forward, then I realized, where is that student going to come from, in the modern languages department or some art department, something like that. Maybe there are, but not too many. And so I thought, well, let's try to maybe, try to solve this problem on a bigger scale. And so we started this organization called Human AI. And it's not just at the University of Alabama, but it does involve a lot of University of Alabama faculty and others, but also it involves others as well. And the idea is that we try to actually build those teams and bring together the domain expert who may not have done any AI work, but they are the expert of the data, the expert of they can define the problem and can tell you the quality of what's happening, with students all over the world through this open source program who have the technical background. And you would be surprised how many of those students from computer science and engineering would love to work on a problem that is just exciting, And now we've done 11 such projects this summer and built already 4 working tools that can be used for that. And that problem, like that the faculty member who came to ask me originally, is essentially solved now, or we made tremendous progress on that. So I think there is something about connecting these two together, and that also requires folks like myself and Gerry and others to actually also bridge the gap, And so there are such fantastic opportunities, and I think we should. If you're looking for ways to, or if you have projects and ideas that fall under this very, wide umbrella, please get in touch and let us know you have ideas and you'd like to take part.
So I think both of the colleagues want to respond to that.
Okay.
There is a panel, so just my little interjection here is that later I think this afternoon, there's a panel with the graduate deans from a number of institutions are going to be having a panel, right? So based on this comment, I'd love those graduate deans to think about, right? What do interdisciplinary graduate degrees start to look like in ways that are not confined within just the requirements of a particular college or a particular school, such that students could really, right, engage in these interesting research questions as they do that kind of work.
Right. Yeah. When you look at what was just said about students and their love for AI, I wear another hat. Okay? And I am over our senior design course, and so what we do in senior design is it's their capstone project, and the interesting thing is. Many of the students have not taken a class in artificial intelligence. And within 15 weeks, they've got to come up to speed pretty quickly. And it's like, well, how do you do that? Well, I think, you know, what we've been doing with these students is we're asking them to start shallow and then go deep. So when we look at artificial intelligence, when we look at machine learning, we have what's known as the shallow algorithms like support vector machines and stuff like that. And we've all heard of deep learning, right? And these LLM transformers, but you know, we can still do a heck of a lot of stuff, right, with these shallow algorithms. And then you say, well, how do they get involved with AI? It's just, you know, do you have a problem? Do you have data? And so, you know, one particular project is with our Department of Educational Leadership, Foundations, and Technology. And so we have Hank Mura and Andrew Pandola. I said I was going to bring him into this, but anyway, they have a weird, well, it's not a weird, it's a cool saying. They say, well, you know, a lot of people, and we'll just see if you fit this category, but a lot of people are drowning in data, but thirsting for knowledge. That's what they came up with. And the way they attacked it was through AI and machine learning. So they wanted to basically come up with a system that could predict student achievement. And they had a ton of data. They had a lot of different parameters. And so they got the students involved. And what we did is we gave them something called Scikit-learn. And then the first thing that we had them to do was something called lazy predict. So in Scikit-learn, you have 15 shallow machine learning algorithms, right? Now, what this lazy predict does is you run it, and it kind of, with all the default parameters, it takes that data, runs it through, and tells you which of those machine learning algorithms performs the best. And then the students will take that. We tell them, we have some videos that kind of teach them, you know, with training sets and whatnot, how to break it up and whatnot. And then they're off into the races. And so then they started automating these algorithms so that they could reduce the number of features to increase the accuracy. And they've come up with an amazing product. And then they turned it to the next semester's group. So the thing is, I think, you know, if you're trying to get into AI, if you have students that are trying to get into AI, I just say jump in. Yeah. Dive in, go into the shallow, and then swim to the deeper end.
But I think that matching part is also important because, right, you happen to know, right, the people in EFLT, but if not, right, so there's somebody else out there. So how do we also help people discover each other, that there are these needs? The capstone design projects are great, right? Then how do we match that up with any needs? Did you have a comment? I'm just going to get the audience primed, right, for this. 1 second. So think about your questions. The microphone will come around as Jim's talking. Go ahead.
Yeah, just real quickly, if we get back to the practical side of it. I'm at Auburn University in Montgomery. We're not an R1 school, not an R2 school. I'm not sure there's an R for us. I mean, we're not in a research school. We're a teaching institution. But what I saw there was, and we started our AI lab with a home-built AI machine, and students started using it, and we started teaching the courses in it. And I talked with NVIDIA, who was very good to us, and we were able to get a DGX station. So we got a pretty powerful AI machine. What I observed is students were coming from all over campus to use our lab. We had students from physics, from mathematics, biology, chemistry, nursing, coming and partnering with business students, because these business students have been taking these courses in AI. And the collaboration was unbelievable and fun to watch. And it starts. And they start doing research as undergraduates and graduates together. And then another phenomenon happened. I was at a faculty meeting once, and there was a proposal for the school to spend $46,000 to buy some finance data to do research on. And I thought, oh my gosh, this was 2.5 semesters into our lab. We have people throwing data at us. We have to turn down data. There is so much that organizations, government entities are interested in getting help with. If research is your goal, just get started. You can start small, but it will explode.
We have a question.
Yes, thank you so much. And my question is actually for everyone.
Would you mind
here.
introducing yourself just briefly?
Yes, I'm Lillian Mina, Associate Dean at the Graduate School at UAB, and I'll be on the panel for graduate schools this afternoon.
I saw you. That's why I picked out your phone.
Thank you. So my question actually is not about students necessarily, but about faculty who are still not on the AI bandwagon, who are still resisting. I mean, I'm not just talking about humanities, it's across the board. UAB is health focused, STEM focused, and we are still seeing lots of resistance to AI among these faculty. So my question is, how about these faculty? What would be, if you are dealing with that group of faculty who are still resisting, not just using AI in their own research and teaching, but they are blocking their graduate students from approaching or thinking about using AI in the research or in writing their thesis and dissertation projects. What's the approach to that? Because this is the stumbling block we are dealing with right now. Thank you.
Any of you?
Yeah, if I could just, I keep coming back to a business perspective. That is not surprising. And I think that's pretty much everywhere. You're talking about people who are not early adopters or innovators. Well, how do you get there? And this is a problem in business. When you have an innovation and you're putting it in the marketplace, you don't sell it like anything that is already out there. You have to do it differently. I think it's going to have to be the same approach in academia. You have to identify the faculty members who are the early adopters and the innovators, work closely with them, understand and let them teach you how they do it, how they're successful. And then when you really have that, then you can start moving into the larger faculty that are just going to be slow to adopt. I mean, this is very common in business, and it's a very common problem. And it's not just business, it's people. I mean, if I would ask you to raise the hand in this room about cell phones, there would only be a few people in here who go, oh yeah, I'd take a cell phone. And everybody else would go, those people are crazy. Now nobody will give it up. And there's a pathway for getting there. And it's going to be the same thing. It will change faster because of the exponential growth. But it's a common phenomena. These guys can probably tell you how to deal directly with it.
No, I think he's totally spot on. And I'm just going to piggyback off of of what he said. I think in these cases, what we have to do is to let faculty know about one thing, and that's called the competitive advantage. Okay, those people that are using artificial intelligence are going to be given a competitive advantage. Now, let's say I am a faculty member and I'm kind of like taking things slow, right? And I'm kind of, change is hard, right? And I may not want to change. Well, will you change for your students? Because see, if your students have an understanding of AI and how to appropriately use it, they get a competitive advantage, right? When people are, when you're looking at students, or, you know, you're going to say, hey, they have this knowledge. They're going to go to the front of the line. Okay, so it's everything that was said earlier, but what we're looking at, what we're striving for with AI is that competitive advantage.
I think if I can add to that, so we actually went through this in my field about 15 years ago. And so coming from experience, for a time, you know, maybe when the algorithms were still maybe not as powerful as today, and the delta between the two, do I use it, do I not use it, wasn't that big. So there were plenty of detractors who said, well, why do I do this? Let's just keep doing the way we're doing it. Now, what happened is that because these algorithms have gotten better and the results got better, the motto is you can't argue with the results. So if you have a 30, 50, 100% gain of whatever it is you want to do, you'd want to use the most powerful tool. You'll be left behind if you don't. So I've seen, you know, that really change this conversation and the landscape within our community, for example, which went from this, you know, minority to really majority now. It's completely flipped. And I've seen some of those same people who have resisted. Some of them, even though they haven't grown up with AI or have used AI in their research up to that point, they were wise enough to actually let their students explore it and with them together. And some of them are now some of the most strongest proponents of it, and they do lots of good things. So people have turned around, complete 180 over, you know, this period, some of them. So I think a lot of it has to do with, you know, it's going to take a few years, but if, you know, it will all be, like you said, it's competitive advantage. People realize it. You know, some of them jump on the bandwagon even though they were against it. Others will actually say, how do I make this better? How do I really embrace it? And I've seen people change their entire, it's also an opportunity for academics to actually, of course, we should be learning new things. And some of them can pivoted careers and have completely new research directions, completely new life almost in their research and disciplines. So that's kind of exciting.
And Lillian, maybe the Nobel Prize in Chemistry this year, especially for your medical type people, right, at UAB, is a great example because, right, the protein folding work that they're now doing, they're discovering new kinds of structures and molecules, right, with possibly great drug design benefits that don't exist in nature, right, but come from studying, right, through machine learning, existing structures in nature, and then taking those protein sequences and making new kinds of materials, right, which could have really great applications. We have a question over here.
My name is Sandra Sutton-Obis. I'm at Alabama State University. And great segue to my question, by the way. The session began with the fact that AI was cited in the Nobel Prize work. And so my question is specifically about citations. I read an article about APA and how they're wanting the citation to not just mention the use of AI, but to include the prompt and to include the text that was developed. And if it were a large amount of text, even a link to display that. And so my question to all of you is, how do you balance transparency, intellectual property, privacy, all of those things with the citations?
I balance it by just telling everything. I used to code years ago. I don't anymore. I get ChatGPT 4.0 to do the coding for me. And I'm finishing a paper now where there's some code in it. And in the citation, I hope I'm getting this right, in the style they want, but I am citing ChatGPT 4.0 with the prompts that I used in the appendix, and so that the results are there. And I do the same thing in the classroom. I encourage my students to use generative AI for answers. I just require them to give me the prompts. And you can tell when they're not telling the truth. It's not hard. But to answer your question as far as the citation, absolutely. And I also do the same thing. That's with generative AI. I also do the same thing with predictive AI. I will put in the appendix, here's the data, and here's all the different parameter or hyperparameters that we set for these models to achieve this. So that if a researcher wants to, and we'll make the algorithms available to any researcher interested. So if they want to try to duplicate the research, they can. But I think the overall answer is provide as much transparency as you possibly can.
Yeah, I agree with that 100%. I think that the thing that I like is when you're putting the prompts there, that's another avenue for learning, right? Because you get a chance to see, hey, well, how did I get this right? Because sometimes it's all about what you do and how you do it. So yeah, totally agree.
Thank you for asking that question. There's a lot of layers to this, and one of it is how do you attribute credit properly to tools and collaborators and lots of different ways. But in some fields, it's also important. Also, like IP is important, and in different contexts and whatnot. What I've observed, and this goes back to maybe what Willis was saying in the keynote talk, is that. I'm a very big proponent of both open data and open source. And what you see now is actually this play out even with the bigger, the large companies that are innovating in the machine learning space. It turns out that it really helps to really undercut your competitors' advantage if they are closed to make it open source. And then what happens is that because you do that, the community goes, all the good things sort of, even, it helps remove this closedness and competitive advantage from doing that. So I think we're increasingly living in this, we are going to be in this open source environment and open data environment. And I think it's actually very positive, and it should help accelerate and also make sure that all these tools end up being reproducible, accessible, and so forth. And I think that that openness that my fellow panelists mentioned, I think it's a big important step for us to make that the way forward, if it's not yet that way.
Thank you.
We have another question here in the middle of the room.
Right. Hello, I'm Muriel Foster from the University of Alabama System IT Audit Director. My question is about, you talked about different tools and you say shallow versus more complex. Could you go into more detail or what they might be? Some of the more common ones we know about ChatGPT and Copilot, but you're talking about something more complex. How do we use those and what are those tools?
Okay, I was calling those complex. Okay, I was talking more about the shallow algorithms are more like I said, support vector machines, those kind of things, right? But we can add complexity onto, when we look at GPT and Chat GPT, we have these retrieval augmented generation. So we've got that can add complexity. We're also seeing this whole notion of agents, right? So you're building these agents, and these agents will now do a task for you. They have the state, they have memory, they know what they've done and what they're supposed to do next. And another level of complexity on top of that is when agents are now, right, communicating with other agents. All right, so yeah, you can get, and it's going there, right? It's becoming ever more complex. So what I was saying is just, yeah, start in the shallow, go to the deep, and then there is a lot more complexity out there.
I wanted to add to this that it's very much dependent also on the type of data that you're working on and for that problem. So if you're dealing with, so these more complex tools like deep learning and things like that, they're very powerful, but they also take advantage of certain symmetries and certain certain features of the data that they can exploit, that neural networks can exploit. But then if you're dealing with, possibly tabular data and other types of things that don't have a certain structure that can be exploited, some of these shallow methods that Gerry was talking about, whether it's random forests or decision trees or all kinds of other things, support vector machines and so on, they may actually be, they're very competitive with neural networks there. So you don't really need a fancy sports car if you're stuck in traffic. A bike will beat you, right? So that's why you don't always need that tool based on the problem. So if your problem doesn't have so much structure in it, perhaps it's a better approach.
Yeah, I'm Jonah Donaldson, UAB, and so what are your thoughts on how AI can help us move out of these older research paradigms that are assuming linear causality?
So I happen to be holding the microphone. Great. So, those kind of issues, and we have this AI lab, and one area we're working in, one area of research is addictive behavior. And we have found a correlation, a strong correlation, just by looking at data, that if I had to look at, in going and visiting these clinics that treat patients like this, their behavior, and I hope I'm getting this right, their behavior in understanding the patient and initiating treatment tends to be pretty linear. And what we've been able to find by getting what I would think is really bad data, meaning there's a lot of holes in it, we've been able to use, because we can get so much data, we've been able to use the AI to find patterns that were a bit surprising. But once you hear the pattern, you go, oh, well, that makes sense. An example is, we found that there's, recidivism is a problem with people with addictive behaviors. We found that recidivism tends to spike when people age from one decade to another, turning from 29 to 30, from 39 to 40. And when I gave this research, the results back to the people in the clinics, they said, why didn't we see that? But we found this with really, really bad data, but we had so much data, we could start uncovering these patterns. And really, that's the goal of the AI, is to uncover patterns that as humans in our brains tend to aggregate things. We can't see that big of a picture. We just use it as a tool to find those patterns for us. And there's others that we're now discovering. We're starting to look at, like correlations between traumatic brain injury. Maybe you fall off your bike when you're a kid and you're in a family that has no DNA markers for addictive behavior, but you're 28 years old and you find yourself an alcoholic, and there's a correlation there. We can't prove causation, of course, but there's a strong enough correlation, to be able to find that. Now, I tell that story because if you're in an area of research where you're finding what is the connection between what I do and AI, it's challenging. It is. It is challenging, and it's not bad. It just gives you an opportunity to think about things from different perspectives and to motivate collecting as much data as you can that you think could be impactful in this. And, they were talking about sort of the shallow tools. One of the more important shallow tools that I think is going to be really helpful is clustering algorithms. And they're very simple. And it takes away, it's unsupervised learning. So it's taking away us telling the system, I want to know more about this thing. How do I predict this thing? And you just let the computer say, find the relationships in here. And it'll find relationships probably that you've never thought of. That's how we uncovered these two correlations. So I think there's a lot of opportunity there, but it's going to call on researchers to be really creative in their thinking and to just use the tool, just experiment. And being at a university, you're in a wonderful place to just experiment. You'll fail a lot, but then you'll start seeing things happen. I hope I've answered.
Thank you, Jim. Sergey has a response, and I have one last closing question for the panel.
Yeah, I want to speak a little bit to your research, and there's actually an exciting, it's interesting you brought this up. There's an exciting angle to this that also has to do with understanding how machine learning works. Because it turns out, and some of it is grounded in physics and statistical mechanics and nonlinear dynamics that you mentioned, it turns out that the way neural networks learn, for instance, you can think of them as like ensembles of neurons, these microstates. And as these layers of neurons are learning, as you're training the model, you start to see emergent behavior happen there. There's phase transitions and all kinds of things, like things that you observe in nature, when you've got ice melting and things like that. When these models are trained and learning, they go through these. So it turns out that understanding that science is going to be absolutely crucial to us understanding how to build better machine learning algorithms and how to understand what they're doing and why they're powerful. So there is a huge potential actually for this type of research to advance AI. Yeah.
Gerry, 30 seconds?
Okay,
30 seconds.
I'll be real quick. Yeah, when you look at these like deep learning, you have the convolutional layers, and this happens with when you're doing image recognition, and we see things like, oh, this is a cat, right, and this is a bird, but when you kind of slice off the that convolutional layer and say, well, what does the actual deep learner look at? It's some kind of weird representation that we wouldn't recognize as a cat or a dog, but for some reason it works. And so to kind of piggyback off of what these two folks said, there's an ongoing research area called explainable AI. So now you get this weird stuff going on. Can you tell me, why it said that was a cat and why that's a bird? So.
Okay, thank you. So going to go a little controversial to close out, right? Because you guys deal with controversial research topics. So when the printing press first came out, right? The first thing it was used for was to print the Bible, right? Lots and lots of Bible printing. That was this thing that almost now got the word that used to be a verbal word, the word of mouth, into people's hands in a written form, right? And there was so spread of religion was a big thing that happened with the printing press. My question to you panelists, if I took all the religious texts in the world and fed it into some AI, could I prove or disprove the existence of God? Or could I start to answer that question? And would somebody possibly try to answer that question? Love to get your thoughts on that. Anyone? Oh, yeah.
Well, there you go. Now, I am so glad you asked that because I started my academic career as a philosophy major.
Okay.
So my answer has to be this. It doesn't matter.
Okay.
Because our religion is something incredibly intimate and personal, and it is grounded in faith. The moment we prove the existence of God, all faith is removed. And now it's another entity that we deal with. I mean, you know, my religious beliefs do not matter here in this forum. But I deeply and profoundly respect those who have deep faith. And I think there's an unexplainable magic to how they go through life. And they seem to grasp and pursue morality in a way that I wish I could achieve, because I want to analyze everything. And so I think it's a fantastic question, but I would have to say, I don't think it matters, you know.
I just came back from.
Okay, oops.
Yeah, sorry. No, just do want to hear your responses. I just came back from Machu Picchu in Peru, right? Which is a half-finished city, right? Why did the Incas abandon all this work they had put into dragging these boulders up the top of a mountain? There was an earthquake, and one of their shrines collapsed on one side. So the Incas decided the gods were unhappy with them for having built that site at that spot, and they abandoned their entire architectural construction and moved their capital somewhere else, right? So there are profound effects here based on your beliefs. Sorry, go ahead.
Okay, I'm going to wade into this question from a different perspective, okay? And that is kind of the perspective that we see with respect of ethics and with respect to algorithm bias, right? So I would like to answer your question with another question, okay? And that is, if we get to the point where we have artificial general intelligence, right? What kind of ethics would you like that AGI to have? Just something to think about.
Sergei, yeah, we'll let you have the first word since you got us started.
All right. Well, I may add yet another layer to this. I thought about it. So ultimately, you know, as humans, we want to, well, I'm a scientist because I would love to understand nature, right? We all ponder these questions. Why are we here? You know, how did we get here? How did this whole thing came to be the way it is, right? And we still have a lot to learn. And as a physicist, as a scientist, I'll be the first to tell you that the things we know are just a tiny percent of what reality really is. We have so much to learn. The more we know, the less we know, how little we know. Okay, it's not that we know less, it's just we realize how much there is to learn. And so what is interesting is that, and I've discussed this with some of the, you know, I want to say some of the most brilliant minds, brilliant theoretical physicists that I've had a fortune to have discussed this with. And there's an interesting idea that I don't know if we'll be able to test this idea or not. That has to do with the universe itself, right? There is this idea that maybe the universe itself, okay, is learning, and it's not static. You know, we're all thinking about it. Oh, there's laws of physics because that's how we see it now, or maybe we can peer back in time with telescopes. And to what we know, the laws of physics, more or less, you know, are still the same, but some things have changed. If you really go from the very, 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 very beginning of time. So one way to think about it also, we could think, well, could the universe itself be a system, a large system, very connected system that's actually undergoing sort of refinement and learning as it goes on? And even though to us these laws look static, they might have been changing and fluctuating in the very beginning. And now we're at this point where those changes are a lot more difficult to notice. So nobody knows the answer to this question, but you know, that also goes back to a more fundamental question: what is intelligence, right? And also what is nature capable of on the very fundamental level, and what drives that? So big question, no answer unfortunately yet, but big question.
Let's give him a great hand. Thank you very much.